Hello everyone! Today we're going to explore one of the most essential preparatory steps in textile wet processing, bleaching. Bleaching is essentially the process of removing natural color impurities present in fibers to produce a clean, white, and absorbent substrate, ideal for subsequent dyeing or finishing. Now, the choice of bleaching agent is never one size fits all. It entirely depends on the fiber chemistry, processing conditions, and end-use requirements. Let's look at the major categories of bleaching agents used across fiber types and their unique advantages. Oxidizing bleaching agents. These are the most widely used in textile processing. They act by breaking down the chromophoric, color-bearing groups in natural pigments through oxidation, converting them into colorless or soluble compounds. A. Hydrogen peroxide, H2O2. Most common agent for cellulosic fibers like cotton, linen, and viscose. Used typically in alkaline conditions, pH 10 to 11, and at temperatures between 80–100 degrees Celsius. Requires stabilizers such as sodium silicate, magnesium salts, or EDTA to control decomposition and prevent fiber damage. USP: excellent whiteness, high fabric strength retention, and environmentally friendly as it decomposes into water and oxygen. Suitable for both batch and continuous bleaching processes. B. Sodium hypochlorite, NaOCl. An older oxidizing bleach, often used for cotton and sometimes for rayon. Operates effectively at room temperature and neutral to slightly alkaline pH. USP: rapid bleaching action and low cost. However, it has limitations. It can cause fiber tendering, chlorine retention, and yellowing upon exposure to heat or light. Environmental concerns also limit its modern usage due to AOX, adsorbable organic halides formation. C. Sodium chlorite, NaClO2, the preferred bleaching agent for synthetic and protein fibers such as polyamide, nylon, wool, and acrylics. Works best under acidic conditions, pH around 4 to 5. USP: produces very high whiteness without damaging sensitive fibers and is effective even at moderate temperatures, 80 degrees C. However, it requires careful control due to possible formation of chlorine dioxide gas, which is toxic and corrosive. D. Peracetic acid, CH3CO3H. A powerful oxidizing agent gaining popularity as a sustainable alternative. Works effectively at low temperatures and over a wide pH range. USP: high oxidative potential, no heavy metal stabilizers needed, and fully biodegradable. Suitable for blends like cotton polyester and protein synthetic mixes where mild yet effective bleaching is required. 2. Reducing bleaching agents. Now in contrast, reducing bleaches work by breaking chromophoric groups through reduction, converting them to colorless leucocompounds. These are particularly useful for protein fibers and some synthetics, which are sensitive to oxidation. A. Sodium dithionite, Na2S2O4, also called hydros, commonly used for wool, silk, and even nylon. Operates at relatively mild conditions, slightly acidic to neutral pH, and moderate temperature, 60 degrees Celsius. USP: gentle action that preserves the delicate peptide linkages in protein fibers, preventing yellowing and harshness. Often used in optical brightening steps to enhance whiteness further. B. Sodium sulfoxylate, formaldehyde, rhongolite. Another mild reducing agent used for silk, nylon, and cellulosic to synthetic blends. USP: provides uniform whiteness and good handle, especially useful where oxidative bleaching would lead to fiber degradation. 3. Specialty or emerging bleaching agents. Modern sustainable processing trends have introduced eco-friendly alternatives. Ozone bleaching, a gas phase oxidative method using ozone in aqueous or dry systems. No chemical residues, minimal water usage. Enzymatic bleaching utilizes oxidoreductase enzymes like lacases to degrade natural pigments, completely biodegradable and energy efficient, though still under development for large-scale use. Summary table: fiber type preferred bleaching, Agent Nature Key, USP cotton, linen, viscose hydrogen, peroxide oxidizing high whiteness, eco-friendly cotton, low cost, sodium, hypochlorite oxidizing fast action, economical wool, silk sodium dithionite, rongolite reducing gentle, prevents yellowing nylon, acrylic sodium chlorite oxidizing high whiteness, fiber safe blends, cotton polyester, peracetic acid oxidizing broad pH range, sustainable any fiber, experimental, ozone, enzymatic oxidizing, green tech, zero discharge, low energy. So, the secret behind effective bleaching isn't just the chemical itself, it's the synergy between fiber chemistry, process control, and sustainability goals. A smart technologist always balances whiteness, fiber integrity, cost, and environmental impact while selecting a bleaching system. Remember, bleaching is not just about making white fabric, it's about creating a clean canvas for color excellence.